So this example, the directions say use the table to determine if the function would be a linear function or an exponential function. So there's two options. It's either linear or it's an exponential function. So you need to know what those are. Linear function is like a line if you were to graph it. So that's when you have repeated addition. So remember, lines have constant slope. As the x increases, the y is going to go up by some constant slope number. You know, add 5, add 5, add 5, something like that. An exponential function is, remember, it starts with the word exponent. That's repeated multiplication. So that's when you have some base number and you're just multiplying that base over and over and over. So that's an exponential function. So you have to see what's happening. As the x is increasing by 1, the y, what's going on here? So it's going from 8 to 4. So it's going down 4, so it's like it's adding a negative 4, right? And then from 4 down to 2, it's like it's adding a negative 2. Those are not the same number. Okay, so it's not repeated addition. Um, if you look at it again, it's got to be the multiplication one, so it's got to be exponential. So if we see what happened, it was 8 divided by 4, so it wasn't this addition. It was like, you know, divided by 2 to get 4, and then 4 divided by 2 to get 2. So it's repeated multiplication. Division is the inverse of multiplication. It's like saying it multiplied by a half each time, right? Times a half. Dividing by 2 is the same thing as multiplying by a half. So 8 times a half, you get 4. 4 times a half, you get 2. So that's an exponential function because it's not repeated or addition, it's repeated multiplication. It's multiplying by a half each time.